Closed doors, I'm a fool for your love.
Alright folks, we've got our Lego table all set up, and to get us all started we're going to make a short video on programming the robot to complete one of the missions on the table. Mission we're going to have a look at is this one here, mission number 4. First part of the mission is to program the robot to lower the bench and take out this bar. So the first thing we're going to do is we're going to look at what our robot will need to do that. Here we have our standard educator robot, just built as the instructions show us. And we're going to need to program it to lower the arm, to drive forward, turn, to lower the bench, turn back, to get the scoop underneath the bar, lift the bar up, and then return home. It can return anywhere into this semicircle or into any of this area here. So before we even look at our computers, we're going to look at positioning the robot. Now, positioning the robot before we start coding is going to be crucial. We want to make sure that the robot starts off in the same position every time. Because if I write my code to program my robot to go forward, turn, that's going to vary if I place it here, or here, or here. So we're going to need to make sure the robot is exactly in the same spot every time. Now to do this, we can use a rig. Now we can place Lego on the table. I'm afraid we can't build our rig out of anything but Lego. So I've built something here that I can place down and line up with the grid to program the robot to maybe face this direction. For this mission, we're just going to use this back wall to place the robot. To make sure it's not angled left or right, I've built a small, actually make sure we can see, I've built a small, I'll move down, there we go. Now to make sure it lines up in the same position, I've just built a small little bracket that I'm going to clip on to the bottom of the robot here. And with this, I can slide it, place it against the back wall, and I know that the robot is facing straight. I'm also going to use this grid and line up the left wheel with this line here on the left hand side of the logo. Alright, we're ready to start coding. So we're going to open up the software on my computer and we're going to turn on our robot. So here we are in our EV3 Classroom software. We're going to get started by hitting New Project. Now in order to control the robot, we're going to need to connect to it. You can connect to it using the USB cable that came in the box, or we can connect with Bluetooth. We're going to connect with Bluetooth. So before we do anything, we're going to need to make sure that we have Bluetooth on our computer enabled. You can do this by hitting the Start menu, searching for Bluetooth, and you'll open your Bluetooth settings. We'll just make sure it's turned on like this. Now we hit connect. It's going to give us some instructions. Turn on the brick, enable Bluetooth. It's showing you an animation of how to do that here. Make sure visibility and Bluetooth are both enabled and hit the tick. With a little bit of luck, we will see our EV3 appear here. And we're just going to hit connect. It's going to ask for a passkey. So we're going to say, yes, we want to connect. And yes, the passkey is 1234. And now, when we hit connect, we are connected to our robot. We can start coding. You'll be able to see up here we have A, B, and C. A is our medium motor controlling the front arm. B is our left motor, we can see it moving over there. And C is our right motor. Okay. Now let's pop our robot down in its starting position. And the first thing we want to do is program it. Oops, if I can move this so we can see. First thing we want to do is program it to drive forward. So over here, I'm going to go to movement. And something that we're going to need to do is set our movement motors, which are B and D. So we can take this block here, and we have set movement motors to B and C. We'll need to change that to D. Now that corresponds to where we have connected our wires on the front. Our motors connect to A, B, C, and D, and our sensors, if we have any, connect to 1, 2, 3, and 4. Now, we're also going to want to set movement speed to about 50%. Just to start out, I understand that the robot game is timed, but for the purposes of programming the robot, making sure everything is correct, we'll probably be best off starting at half speed and then slowly increasing the speed to see how quickly it can go without losing accuracy. Alright, now our first job is going to be to lower our front arm. So we'll start it off in the same position every time, right here at the top, just like we do with the robot. And we'll go over here to motors. And we have this one here. Run A clockwise for 1 rotation. Let's see what happens if we run this code. So we'll just hit the play button and it should run the code on our robot. Okay, so you can see that this yellow highlight is still around these blocks. It hasn't finished this piece of code. It is still trying to complete it. And the reason for that is that it is trying to lift the robot arm up. It's going the wrong direction and it can't finish its 1 rotation because there's something in the way here. So we're going to need to stop that. We'll just hit the cancel button here. It'll reset. We now know that we want motor A to run counterclockwise, and we'll see how far 1 rotation takes it. A little bit too far again. You can see that it's stuck and it's still trying to push down. Now it won't move on to the next piece of code until it completes turning the motor 1 rotation. So we're going to need to lower that quite a lot. We can stop our code by hitting the stop button on our computer and reset the arm. Let's try maybe half a rotation, 0.5 rotations. Now we can also choose degrees or seconds, but we're going to go with rotations because I feel it's the most accurate way for the movement motors to control where the robot goes. So let's keep everything simple, we'll keep it all rotations. It looks like it's gone a little bit too far again, and it's still not able to complete its movement, so we'll need less than that. Let's try 0.4 rotations. Reset and download again. That looks just about right to me. So that should be at the right height to reach underneath the scoop and to lower the bench. End the program, reset it, and reset our bench. Let me just try and get a better angle here. That looks good to me. So we've lowered the arm, now we need to move the robot forward. So we'll go back to movement, and we'll say move straight for 1 rotation. Now 1 rotation is going to be 1 full rotation of the wheel, like that. And the reason we use rotations is if we set it to seconds perhaps, if it runs for 1 second and the batteries are full, it's going to move a little bit further than if when the batteries are drained a little bit. So move forward for 1 rotation. Let's see what this brings us. Not quite far enough. Let's try 3 rotations. And a lot of the coding is going to be trial and error, just like this. You're going to need to test your code, make small adjustments, test it again. Now that's a little bit too far. You see it bumped into the bench and turned a little bit crooked. Gonna need less than 3 rotations, perhaps maybe 2.5. So let's change this number to 2.5 and go again. I'm not quite sure if that is far enough. We need a little bit more than 2.5. Let's change it to 2.7. I'm going to leave the camera here. Move forward for 2.7 rotations. Alright, that looks just about spot on. Now I've noticed that the arm is just rubbing on the underside of the bench, so I might even lower that slightly more. So we'll tell it to run motor A for 0.45 instead of 0.4. We've moved forward just the right amount, so now we're going to need to turn. So let's run motor D forward. So we'll go back here to motors. And where are we? This will do. Motor D. I think 1 rotation is going to be too much, so let's try a half. Keep our speed at 50. Now let's put that all together and give it a go. Make sure our robot is lined up. and run our code. That looks pretty good. So now we're going to need to program the robot to turn back out, drive forward, lift the arm, and then reverse back into home. So how are we going to do that? Let's tell it to move backwards. Oh, can't quite do that. I've chosen the wrong block. We want to take this one. Move backwards, let's say for maybe even less than half a rotation. Let's go with 0.3 rotations. And we're going to need to line up our car once again. So we're going to need to show you here. So drive forward, run motor D for half a second. Then we're going to need to run motor B to get the scoop underneath the arm. So let's take this motor block again and we can say run motor B for 0.5 rotations at half speed. And if this code works out the way we want, it should end up with the scoop right underneath the bar. So let's program it to lift the bar. So counterclockwise is lowering. Let's tell it to move clockwise. And let's tell it to lift maybe 0.4, something a little bit lower than this one here. Okay, let's test our code. Ooh, not bad. What went wrong there? Let's watch that again and see if we can figure out what we might need to change. I think we've moved back a little bit too far after we've completed our turn. Let's pop this back up here. That'll do. So when we move backwards for 0.3 rotations. Let's change the amount that motor B and motor D turn when it's positioning itself underneath the arm, and have a look at what happens. If that doesn't work, we'll go back here and change our move backwards. Oh, we can see what happened there. We started with the arm not fully locked in its starting position. Let's try again. Not bad. I think we're almost there. So before it lifts the arm, let's tell it to move forward just a little bit. Move forward for 0.4 rotations to make sure it goes a little bit further than it moves back. And let's run this code. Excellent. Alright, and the last thing we want to do is have our robot finish up inside home or inside home on this left hand side. So the last thing we're going to do before we finish our code for this mission number 4, the bench, let's make sure we name our project. And the final thing we want to do is tell it to move back into home. So we can say backwards for 2 rotations ought to be enough. Let's take our camera up down here so we can see. And there we go. Spot on. Alright, well done folks. We have programmed our very first mission for this year's LEGO League replay. Now, before we finish up, now that we've saved our code as mission number 4, bench, you'll notice that on our robot, this play button is our most recent programs. You'll see mission number 4, bench, and also here in our program manager you'll find a folder inside which is mission number 4, bench. Now remember, when it comes to competition day, we won't be able to use our computers to run the robot because we won't be able to edit our code during the 2.5 minutes that we're running the game. So we're going to need to make sure that everything is well labeled, and we're going to run it just using the robot like this. Okay, good luck folks, have fun, and we'll see you on competition day.
Closed doors, I'm a fool for your love.